Hello everyone, this is lecture 3 for the module 1, and in this lecture I am going to talk about the performance assessment of the computer system, how to measure the performance, how to assess the performance of your computer system, what are the criteria are there, what are factors which we need to consider to measure the performance of a computer. In this I will talk about the CPI, number of cycles per instruction, MIPS rate and benchmark programs and so on. So, first of all look at what are the key parameters. So, in computer basically when you try to purchase some computer or you are looking some computer for your programs or for your organization to purchase the computer, you need how to look at that what sort of machine you are going to purchase. So, the performance is one of the key parameter for evaluating the processor hardware, that is the one thing, and other is the measure the requirement of a new system. Means when you go for a new hardware, purchasing new hardware, you have to measure first your requirement as per your organization demand, and then you propose some system for that. So, when we say one computer is better than another computer, so what does it mean? Say computer A is better than computer B, so what is the meaning of that? In normal terms, how to measure or how to say that okay, one computer is better than another means we want to know that what is the criteria for the performance. The very simple thing comes very first time in our mind is that the speed of the computer is the major performance criteria. Let us say one computer or one processor speed is 2.0 gigahertz, another processor speed is 2.4 gigahertz. So, I say that the 2.4 gigahertz processor is faster than 2 gigahertz. So, that is a very initial perception about the performance or measuring the performance of the computer. So, essentially from the speed what we are looking, for a single computer let us say the speed can be one criteria, or if the speed is more, then definitely response time also will be will be less. So, for a single computer the criteria can be the response time. Response time means the amount of time the computer takes to complete the job, how much time it took. Less time is taking means it is a faster machine, if taking more time then it is a slower machine compared to that. For example, in data center kind of scenario where the multiple servers are there and multiple users are submitting their jobs to complete or to execute, in that case the performance criteria is different, where the performance criteria is throughput, means the number of jobs completed in a unit time. So, for a single computer response time can be one of the criteria. I am not saying this is the only thing to do it, but let us say response time is the criteria, and for data center kind of thing it is a throughput can be a criteria, better criteria for measuring the performance. So, it depends upon context to context. So, now let us say we want to measure the performance in terms of the speed for a single computer, for making the discussion in simple. So, speed means we need to find the time, the execution time, and for execution time we need to talk about how the processor executes the program or instructions. So, processor operation operation performed by the processor are basically governed by the system clock, and that clock is generated by a crystal called as a quartz. And this is the fundamental level of processor speed measurement. Each and every operation which is completed or executed in the processor requires some clock cycles, or it is measured in terms of, or it is governed by the clock cycles. So, what is clock cycle? It looks like this. So, you can see here the clock is continuously running with some frequency, fixed frequency. Frequency means the number of cycles per unit time. That is a measurement of the clock cycle or unit of the clock cycle, number of cycles per second or per unit time. And this is the clock period, one up and one down, that makes the clock period, the duration of the clock, at what frequency or at what rate clock is running. More the clock speed is there, we say that processor is faster processor. But in each clock duration, processor is doing something, some part of the execution it is completing. So, all the operations in the processor are synchronized with respect to the clock. Now, what are the operations? Operation can be transferring the data from one register to another register, can be one operation. Transferring data from memory to one of the processor register and vice versa, or performing some ALU operation. These are all the operations. It is not always mandatory that each operation will take only one cycle. It may take more than one cycle as well, depends upon the operation to operation, or at what granularity you are describing your operations. So, a clock cycle is the basic unit of time to execute one operation, as I said. It may take more than one operation, and it is measured in terms of clock cycle per second, or that is called as a clock rate. And another factor is the clock period. And for higher frequency, we measure in terms of megahertz or gigahertz or terahertz, like that. So, giga means 10 is to the power 9 cycles per second, mega means 10 is to the power 6 cycles per second. Now, the question is whether this clock rate is enough, or we need to think about some other parameter or other factor to measure the performance of the computer. So, let us look at, we know that the instruction execution is happened in several discrete steps. It is not a one atomic step. In the lecture 2, we have seen that instruction execution is basically divided into various steps, and these steps are fetching, decoding, ALU operation, fetching the data, like that. Now, and each operation like fetching, it takes some cycles, decoding will take some cycles, ALU operation will take some clock cycles, or it will consume some cycles. So, your instruction or each instruction is taking multiple clock cycle for its execution. Now, that is for the one instruction. Now, we have the different type of instruction in a instruction set architecture. We have the arithmetic instructions, we have the logical instructions, we have the control instructions called as the jump instructions, or some ALU operations like addition, subtraction. So, different type of instructions are there. Now, for each instruction the number of cycles are required also will be different. So, what I mean to say here, that simple speed is not enough, because suppose on one machine I am running a program with some different set of instruction, another machine I am running a program for different set of instruction. We know that even the ISA is same for both the machines, but in that case also for one machine, that one machine may be faster than the another machine because of the program which I am running is different programs I am running, and different program means they are using different set of instructions. Say for example, load instruction usually take more time compared to the add instruction, because in the load the memory reference is involved, and we know that the memory is slower than the processor speed. So in memory, fetching the data from memory will consume more cycle compared to some ALU operation which is to be done in the hardware or processor inside the processor. So any instructions for which the processor has to interact with the IO module or memory module will take more cycles compared to the operation which is completed in the processor itself. So means the different set of instructions will give the different execution time, and then we cannot say that okay, the speed is the only criteria for measuring the performance. So the conclusion is the clock speed does not tells the whole story. So now come to that the performance which is application specific. So if I want to compare two computers or two CPUs, I have to run the same program on these two computers, and then only I can compare them. Okay. So the performance basically we are looking in terms of the given application, and application performance depends upon the speed of the processor, instruction set, right now we are not considering, choice of the language, efficiency of the compiler, and the programming skill of the user. These are the parameters on which the application performance depends. Now we try to measure the performance of the computer. So we found that execution time is the one criteria. If I am running the same program on two computers and measure the execution time of that program in each computer and comparing, and on the base of this the judgment can be taken that which computer is faster and which computer is slower compared to each other. So my performance equation is the performance is inversely proportional to the execution time. Let us say here a constant which to remove the proportional thing, the constant is let us say 1. So in that case performance is equals to the 1 upon execution time. Less the execution time, more the performance. So if I want to compare the two computers or two processors, let us say X and Y, and if I say X is n times faster than Y, then what will be my equation? My equation will be the performance of X computer divided by performance of Y computer is equals to the execution time of Y computer divided by execution time of X computer, and that is equals to n. So this equation tells me that X is n times faster than Y. Now the another factor which used in measuring the performance of the computer or performance of the processor is the cycles per instructions. We know that for any given processor, number of cycles required, that is varies from different type of instructions. As I mentioned in the previous slide, load instruction takes different number of cycles compared to the add instruction. If I assume that in add instruction the operands are available in the register, in that case a load may take more times because the memory access is involved in that. And we know that the different type of instructions are there, like load, store, branch, add and multiplication, these different type of instructions are there. So the cycle per instruction is not a constant value for the processor. If all instructions are taking same amount of cycles, then only we can say the CPI is same, cycle per instruction is same, but the instructions are different and they consume different number of cycles for the execution. So for calculating the execution time, we need the CPI of that processor. So, we have the different sort of different type of instructions supported by the processor. I am talking about the instructions at the low level instructions, not the statements, not high level language. The native language of that machine is assembly language or machine language. So, we need to calculate the average CPI for the processor, because the different type of instructions are there and they consume different number of cycles. So, to calculate the program execution time, so the amount of time taken by the program to execute. So, if I know the number of instruction in the program, that is IC, multiply by CPI, cycles per instruction. Let us say this is average CPI is written here, because I have to take the average of different instructions, multiply with the T. T is the cycle time. So, for calculating the average CPI, I have to find out the CPI for each instruction, each type of instruction, and then how many instructions for each type are there, and multiply everything and take the average of it. That will give me the average CPI. The CPU performance also depends upon the amount of memory access. So, instruction execution, some instruction execution require memory access, some instruction execution does not require memory access. So, if I want to consider the memory access into the total execution time, then this total execution time equation will modify by IC into IC multiplied by P plus M cross T, sorry, M cross K into T. Here P is a processor cycles, means the operation which is done inside the processor, or M is the memory references, and K is the ratio of memory cycles to the processor cycles. So, K is more means execution time is more, K is less, the execution time is less. So, it depends upon how many memory cycles. Memory cycles means the amount of cycles which are consumed in fetching the data from the memory or storing the data into the memory, any memory related operation, compared to the cycles consumed by the processor for the ALU operation or for shifting the moving the data from one register to another register and so on. So, these performance factors like cycle time, CPI, memory references, or ratio of the memory references to the processor, ratio of the memory cycles to the processor cycles, these factors, these performance factors are influenced by the ISA, instruction set architecture, compiler, processor implementation, and the memory hierarchy. The memory is not a single unit in the processor. The lowest level of the memory is your registers, then you have the cache memory also on chip cache memory and the off chip cache memory, then the main memory, and the different levels. Cache have the different levels, level 1, level 2, level 3. So, it also depends upon that, from where the data is fetched, what is the hit ratio of the memory, cache memory, that also, it also depends upon that, because the access time for the cache memory is lesser than the main memory access time. So, how many data are fetched direct from the main memory compared to the cache memory, that ratio is also important. So, equation becomes complicated, we can understand from here. The term here which I am introducing is the MIPS rate. MIPS rate says the instruction execution rate only, but the quantity is that million instructions execution rate, million instruction per second, that is called as a MIPS rate. MIPS rate is defined by IC divided by T into T is the total execution time, T into 10 raised to power 6. So, 1 mega instructions, 10 power 6 instructions per second, that is a MIPS rate. So, this can be written as by using that formula is the total execution time T equals to the number of instructions into CPI into the clock rate time or clock time. So, if I use this equation, so this MIPS rate can be written in the form of, so IC by T if I apply this IC by T, then it will give me either 1 upon T into CPI into 10 raised to power 6, or 1 upon T I can write 1 upon T equals to F frequency, because F equals to 1 by T, frequency is inversely proportional to the cycle time. So, then I can write this MIPS equation with F divided by CPI into 10 raised to the power 6. So, this is my performance equation in terms of the MIPS rate, and that is the very common measure of the computer performance. Now, let us take one example. Let us say processor speed is 400 megahertz. There are 4 types of instructions with CPI. So, each type of instruction have the different CPI, cycles per instructions. Number of cycles required to execute that type of instruction is 1, 2, 4 and 8 respectively. Having the instruction mix, the mix in the program is 60% of type A, 18% of type B, 12% of type C and 10% of type D with respect to the 1, 2, 4, 8 their CPI. So, we need to calculate the MIPS rate. So, for calculating the MIPS rate, what I need the average CPI for that, because my formula is what? F divided by CPI into 10 raised to the power 6. So, F is given, processor speed is given 400 megahertz. So, 400 into 10 power 6 is the frequency. So, I can write here 400 into 10 raised to the power 6 is my frequency is given, processor frequency is given. Now, average, for calculating the average CPI, the instruction mix is given. So, I say 0.6 into 1 plus second type of instruction is CPI is 2 and the proportion is 18.18%, 18%, so 0.18 into 2 plus 4 into 0.12, 0.12 and finally 8 into 0.1%, and this will give me roughly 2.24. So, the average CPI, I should write average CPI for this machine is 2.24. If I put the value average CPI in this formula, so in place of average CPI I will write 2.24 and will calculate, it will give roughly 178. So, 178 is a MIPS rate of this computer, means 178 million instruction per second can execute. Now, what is the limitation of the MIPS rate? Is the MIPS rate is also not a very good criteria, or let us say it is not sufficient to measure the performance of the computer. Essentially, measuring the performance of a computer is, it's a very complex task. It's a very complex, you can say, the operation for that. Why it is complex? Because there are a lot of parameters. What we are trying to see, we are trying to look at from, let us say, just speed we consider. That is a one, you say that basic criteria in terms of the execution time. So, that is the simplest one, but there are a lot of other factors are also there which makes this calculation complex, and we are looking at one by one. So, MIPS rate is a one, let us say MIPS rate means the instruction execution rate. The more instruction is executed by a processor means compared to another processor means that processor is faster or its performance is better compared to other. So, why the execution rate is not sufficient criteria or why it is inadequate? So, the first answer for this is because of the different instruction set architectures are there. So far I have not talked about the instruction set architecture. Suppose the two machines which I am going to compare in terms of the performance, I have not looked at it what is the ISA of these two computers. If ISA is different means the basic operations performed by each computer is different. The number of, maybe for addition one ISA is performing let us say one instruction and at lowest level, and for other computer for addition operation that ISA is performing 4 operations, fine. So, let us take one example to understand this. So, example is, for example, to execute a high level language statement A equals to B plus C, assuming that A, B, C are in the memory, that may need the different number of may need the different number of low level instructions for different ISA. So, let us say one ISA says that it execute like that, add A is my destination, B comma C. So, it is adding B and C from the memory. So, reading the B and C from the memory and the result, addition result of B and C storing in the memory location A. So, that is a one instruction and it takes some time, and that is a one ISA, some time, let us say it takes some time t. Now, another ISA, that ISA execute this A equals to B plus C at the lower level like that, load A comma R1 comma A is the source and this is the destination, R1 is a register, A is a memory location. So, the contents of A memory location A is loaded into R1, then content of memory location B is also loaded in, B is loaded into R2 register. Now, these two operands are available in A and B, or okay. So, B and C are operands. So, I should say here this is C and this is B. A is my final destination as per this statement. So, I should follow this. Now, then add instruction is adding the contents of R1 and R2 and putting into the R3 register, fine. And then now R3 have the final value, this has to be put into the register, memory location A. So, for that I have to use store instruction. So, store A and source is in R3. So, R3 contents will move in A. Same task is done by both the processors. So, you can see here same task is done by both the processor, that is A equals to B plus C. Let us say both are taking same amount of time, execution time is same, but internally one processor is executing this A equals to B plus C by a single low level instruction or assembly level instruction, and ISA2 is executing with the 4 instructions. So, in terms of the MIPS rate, I will say this is 1 MIPS. The rating of this processor is 1 MIPS, a rating of this processor is 4 MIPS. So, MIPS rate of this processor is higher, but MIPS rate of compared to this, but they are taking the same amount of time to execute this, means performance wise both are same, execution rate wise both are same, but MIPS rates are different. So, that means MIPS rate is not as sufficient or it's inadequate to measure the CPU performance. So, from this example we understood that how the MIPS rate is inadequate for the measuring the performance due to the measuring the performance of the processors due to the different ISAs of different computers. So, now what is the criteria people are using for that, for measuring the exact performance? So, for that they are using the benchmark programs. Only one program is not sufficient. We need to run the bunch of the programs to test or to measure or to compare the performance of the two processors. So, benchmark is, it is a collection of programs that provides representative test of a computer in a particular application area. Benchmark programs are also differ in terms of for what kind of programs. Say for example, SPEC CPU, SPEC is the benchmark, one set of benchmark programs. It is called as a System Performance Evaluation Corporation. They provide some benchmark shoots for that, for measuring the performance of the computers or processors. So, one of the benchmark program from SPEC is SPEC CPU 2006. It is used for measuring the performance for the computational based applications. Like that, it can be, this is a computational based, most of the operations are done in the processor. ALU means highly computational, very less references for the memory or IO. Similarly, a different SPEC or a different benchmark program is there for the applications which are highly IO intensive or requires memory access or IO access more. So, for testing comparing the processors for these, for highly IO related applications, we need to use that benchmark program. So, for the different type of applications, IO intensive application or computational intensive application, or for high floating point operation related applications. So, for different type of application, different set of benchmark programs are there, and for comparing or for measuring the performance of a computer, people used to run these benchmark programs on the set of machines and then come to the conclusion, say which machine is better compared to other for this particular type of application. So, performance is highly depend upon the kind of applications. There is a first thing, and performance also depends upon the how the inside ISA is there, instruction set, how the internally instructions are executing inside the processor. It is not only the execution time or speed of the processor is not, they give just intuitive idea about the processor, but to get the exact information about the performance of the computer, the benchmark programs are the ideal for doing this job. So, let us summarize what we discussed today. The computer performance assessment, the various criteria, various factors which influence the performance of the computer, and the execution time of the program can be calculated by the number of programs, number of instructions in the program, clock cycles per instruction multiplied by the clock cycle time. So, number of instruction in the program and clock cycles per instruction, CPI, this that gives actually if multiply with the clock cycle time, that gives me the execution time. Then MIPS rate, which is commonly used to measure the performance of the computer, and finally to overcome the problems with the speed, measuring the performance with only with the speed and the MIPS rate, that we use the benchmark programs. So, I talk about little bit about the benchmark programs and their uses to compare the performance or measure the performance of the computer. So, now come to the review questions. So, first question is to consider two implementation of the same instruction set architecture. So, here I am saying that ISA is same. So, then the execution time is a valid thing to compare the performance of these two computers. Same ISA, computer A clock cycle time is 250 nanosecond and CPI of 2 for a program. So, for one program, let us say this program contains some set of instruction and the average CPI for that program is 2. For that computer with cycle time 250 nanosecond, computer B has a clock cycle time of 500 nanosecond and CPI of 1.2 for the same program. Program is same, ISA is same. So, then it is a valid to compare these two machines. So, now the question is which computer is faster for this program and how much it is faster. This is the first question, and the second question is a program runs on a computer A with a 2 gigahertz clock in the 10 seconds, another computer B with 4 gigahertz run this program in 6 seconds. So, to do this, computer B will require P times as many as clock cycle as computer A to run the program. So, number of clock cycles are more in computer B. So, you have to find out the value of this P at for what factor B requires more cycles compared to A. So, here for this I am solving the first question and second question for your exercise. You just go through with the lecture and you will find out the solution of the B or the second problem. First problem I am solving here. So, let us solve this first problem. This problem talks about the performance comparison of the two computers having the CPI is given and the cycle time is given for the same program and both have the same instruction set architecture as well. So, we can compare with respect to the execution time and the performance can be measured. So, to find out the performance difference between these two computers, first we will calculate the execution time for computer A. So, the cycle time is given 250 nanosecond, CPI is 2 and the number of instructions in a program let us say assume is I. So, it gives me 500 nanosecond into I. For the second computer B, the cycle time is 500 and the average CPI for the instruction is 1.2 for this computer and the number of instruction is I because the programs are same, both programs are same. So, it gives me 600 nanosecond into I, that is the execution time. Now, as per the performance equation, we know that performance of A computer divided by performance of B computer is equals to the execution time of B divided by execution time of A. Execution time of B is 600 ns into I, ns stand for the nanosecond, and execution time for A is 500 nanosecond into I. If you divide these two, we will get it, this will be cancelled and we will get it 6 by 5. So, 6 by 5 means it is a 1.2. So, I can say here the computer A is 1.2 times faster than computer B. So, the next problem I hope that you will be able to solve it with the help of this lecture recording. So, thank you very much and have a nice day.